We go to the next effects, chemical effects. Chemical changes go more slowly at lower temperature. Or the reaction, if we lower the temperature, we lower reaction rates. This you study in biochemistry, right? However, during freezing, we have one issue, especially during slow freezing. The reacting substances là những chất phản ứng are more and more concentrated in the unfrozen water, in still the remaining liquid water, making them collide each other faster and then react faster. Okay, so there's a critical zone of temperature. If you go slowly through 0 to -5, the freezing is slowly, and then there is a lot of time for the reacting substances to react to each other. So these are two like opposite effect. Lower temperature, lower rate, but more concentrated substances, higher rate. When we talk about chemical effects, and we talk normally about fat rancidity, oxidation of fat, or hydrolysis of fat. The worst temperature for rancidities are about -2 to -4. This is in the critical zone, you still remember. Oxidation causes a stale flavor in store frozen meat, and then which limit the sell life of the product. We have two types of rancidity, lipolytic rancidity and oxidative rancidity. Lipolytic rancidity is because of the enzyme, okay? The enzyme that hydrolyzes the fat. Oxidative rancidity is because of the reaction with oxygen. These are the factors which stimulate or accelerate the rancidity development, especially the rancidity due to oxidation. These are the factors that stimulate air and oxygen. When you have air, then you have more oxygen, light, because the energy of photon, the energy of light can activate oxygen, can make it into more active oxygen species. I think you should review with biochemistry. Okay, you have more light, you have more intensity of oxidation. Softer fat. Softer fat means more unsaturated fat. More unsaturated fat means more double bonds. Double bonds are not as stable as at monobond, as single bond, right? So double bonds are more sensitive to oxidation. And blood pigments, like for example iron in the meat also stimulate the oxidation, because iron is it can catalyze the oxidation, because it can give what is that, electron. It's reducing agent. Okay, it is a reducing agent when it can oxidize other substances. You go to some shop along the street, you see that they hang like roasted peanut in transparent packages. They hang along the street with a lot of sunlight. And when you buy this, you eat, most of the time, you actually eat oxidized oil already in the product. Now we talk about physical effects. Fast freezing. When we do fast freezing, we have many but small crystals. And now we discuss one more important point. Because when you do fast freezing, you reduce the temperature fast both inside and outside of cells. So you see they are formed simultaneously inside and outside of cells. These are cells of meat, for example, or cells of microorganisms, but generally of meat. Here, fast freezing, because the temperature is reduced outside and inside very fast, so you see the formation of small ice crystal both inside the cell and outside the cell, everywhere. When you do slow freezing, the temperature is reduced mostly outside first, right? So you have less number but larger crystal, because there is time for the crystal to grow. And then you have lost crystal mainly outside of the cell here. Only they draw here only one inside and many outside. Many outside mean the osmotic pressure outside is high, right? Higher. Means that water from inside the cell will migrate outside. And as a result, you have some dehydration of the cell's contents. Okay, when you thaw, actually here they do not draw, but some lost crystal may break the cell membrane. Lost cell can also break the cell membrane. So this is called mechanical impact of lost crystal, and this is called osmotic pressure impact of slow freezing lost crystal. Okay, some cases we have fluctuation of temperature during frozen storage. For example, when the electricity is out, then the temperature may rise up and go down again. Or in a supermarket where people just open and close the door of freezer all the time. The temperature can go up and down, okay? Sometimes they open the freezer and forget to close. When the temperature rises to above freezing point, some ice is melted, especially the small crystal will melt. And then when the temperature falls down again, the ice is reformed on the remaining crystal, causing them to grow. Okay? And then after time to time like this, the small crystal disappear, now becomes slow freeze. Okay? For example, in a freezing factory, they do fast freezing of your food. But now they sell in the market, if there is abuse of temperature like this, time to time, the small crystal disappear, become lost crystal, it becomes slow freezing, and then this may influence the food. One example you see clearly that you eat ice cream. You know ice cream? Okay, you buy a box of ice cream. The first time you take it out of freezer, you use a spoon, you spoon it easily and you eat. You and your friend eat part of it, and this part is somehow melted because you sit there and you talk during eating, right? And this part is melted somehow, and the remaining you don't finish, you put in the freezer, and this part is get frozen again, right? Freeze again. And then the next day you you eat and you talk, and this part is a little further melted, but then you don't finish and you put in freezer again. And in several times, and then after the third or the fourth time, you cannot use a spoon to take it anymore. Why? Because it becomes so hard. I think you feel this when you eat ice cream. Now you feel it's too hard. You cannot spoon it easily anymore. Because if you do many times like this, melting and forming of ice crystal, now the ice crystal become large. And then you have a whole batch of ice. Then it's become very hard to spoon. When they make the beginning ice cream for you, actually the crystal of ice are very small. Where are also a lot of air cells, cell of the air. So you can spoon easily. But here you see the ice crystal are large. It will break the air. You will release the air. You lose the air, and the crystal become lost and difficult. You can do this experiment at home. Okay, now during freezing, during frozen storage as well, we may have sublimation of water, of ice, sorry. And then we have weight loss. What is sublimation? Conversion of ice into vapor. Okay, why this happen? In your freezer, for example, so actually the temperature within the freezer is not the same everywhere. Maybe the part near to the wall is colder. For example, this is like even minus 25, minus or minus 20 degrees C. But the temperature here may be like minus 10 degrees C, for example. What happened? At lower temperature, the vapor here, when it goes to lower temperature, then it will increase relative humidity. When the relative humidity reach a 100%, vapor will condensate at lower temperature surface, and then it's become ice. After condensation, it's become ice because the temperature is too low, and then the air inside this become drier, right? So the ice of your food will sublimize more because the air outside is too dry. Especially if you do not package, if you do not cover your food will become drier and drier following the storage time. You will see this in your freezer at home. You buy a piece of meat, you put in a freezer. If you don't cover it, if you don't put it in a bag and so on, you will see that after 1 week you open, you see that the surface is very dry. Okay, and then why this happen? Because for example, water condense on the coils or the plate where the temperature is lowest part, and then the air become drier and water vapor is then draw to where the lower relative humidity is, and so on. And then moisture evaporates from the food and you have weight loss. You even have freezer burn. What is freezer burn? This in Vietnamese called cháy lạnh, but it doesn't mean that there is a fire, whatever. What is freezer burn? This is the result of too much sublimation. The surface is like this. You see this in your freezer time to time. You lose water. If you lose too much, you have this appearance and you call this freezer burn. If you have little freezer burn in early stages, for example, small white spot and so on, then after thawing, this spot will disappear. Take up the heat, vapor again, the water again, and then it's look okay. But if it's severe freezer burn for a long time, after you thaw, you still see this. Will this be toxic for human consumption? No, it's not that the food become toxic. It just influences sensorial quality. Okay, how to prevent freezer burn or how to prevent weight loss? Packaging. Okay, if we do effective packaging, then we can use a material with moisture proof. Moisture proof means prevent the penetration of a vapor. Then we can avoid freezer burn or weight loss. Prevent the damage of the package during transportation and so on. Still air stores are better than blow air store. Okay, for example, if you put in a freezer, if you don't do packaging, and you put in another freezer with a lot of air moving, ventilation of air. More ventilation, more sublimation, more weight loss. These are the cases that we don't pack. If you pack, then it's okay. What is the effects in terms of color? Red meats become darker, more brown and gray when we do freezing. Poultry, that meat, rabbit, and game birds also may have a purple appearance when frozen. And poultry white meat is red brown if frozen slowly, cream to white if frozen rapidly, and so on. This is what you need to read. Anyway, when we do freezing, normally the color become darker. That is how we say. Drip loss. What is drip loss? Drip loss is after thawing. This you do at home, you can actually see. You put your frozen meat in a bowl, in a plate, and you let it thaw, and then you will see that certain amount of liquid is released out, right? You see this at home, and that is called drip loss because you lose the drip. Slow freezing and fast freezing, which process that cause more drip loss after thawing? Slow or fast freezing? That's called more drip loss? Slow. Why? Slow freezing, you form lost crystal outside or inside the cell? Mostly outside the cell. So the lost crystal may break the cell and also cause higher osmotic pressure outside. The water from the cell will release out. And then this one also breaks. So when you thaw, this water will go out and you have drip loss. Slow freezing will cause more damage after, more drip loss. You buy frozen meat from the market, go home, you thaw, you see some amount of liquid release. But when you freeze your meat at home, when you thaw, you may see more liquid because the way you do freezing at home is slow freezing. And the way they do in industry is normally fast or ultra fast freezing. Flash freezing is actually called cấp đông in Vietnamese. Có nghĩa là gì? Khi mình nghe cái từ cấp đông là mình phải hiểu là lạnh đông rất nhanh chứ không phải là lạnh đông nhiệt độ rất thấp nha. Nó khác nhau. Chính xác là phải làm tốc độ nó nhanh. Okay. Drip losses of meat upon freezing and thawing, and consequently the potential losses when the meat is cooked. When you cook, you even lose more liquid come out, are greatly affected by the rate of freezing. The faster the meat is frozen, the lower the losses. Okay, the storage life of frozen meat. When you do chilling, when you store meat at room temperature, maybe you can store only several hours, 6 hours, 4 hours. When you store in a refrigerator, chilling condition, maybe you store like 1 week. But now when you store in frozen condition, it's not days, a week anymore, but it's become what? Month. Why the shelf life is much longer for frozen storage? Because when you do frozen storage, microbial growth is no more. Because the chemical reaction rate is very slow. Because the biochemical means enzymatical reaction rate is very low. And then the cell life is longer. They occur very slowly, but they still occur, mean you still have a cell life. If everything does not occur at all, means that the cell life is forever. But you do not have a food which lasts forever. Means that some changes still occur inside. At frozen condition, the changes are very slow. So you can keep your product for a longer time. Okay, and if you look at this, whatever.